Here we have another diagram on page 6 of the Earth Science Reference Table. And as usual, we'll take a look at the title first. So this is the scheme for igneous rock identification. So you're going to use this particular diagram in order to answer questions about igneous rocks. And this is one of the more complicated diagrams in the reference table, only because there's quite a bit going on. We have essentially three parts to this diagram. The top part is about igneous rocks themselves. The middle section describes characteristics of igneous rocks, and the bottom section is all about mineral composition in a given igneous rock. Right? The next thing we want to look at are these kind of smaller column headings within the table for igneous rocks. So what am I talking about? I'm talking about environment information. We can have extrusive or intrusive igneous rocks. We have crystal size, and we have texture. Crystal size and texture are visible characteristics. So if you look at a rock, you can actually figure out what is the crystal size and what is the texture of that rock. And by texture within rocks, we mean visible characteristics. It's not how a rock feels. So it's very different than the common usage of the word. So how do we start using this diagram? We want to focus first on this upper part where we're looking at both the environment information, crystal size, and texture in order to kind of figure out the various rock names. So everything within this rectangle are rock names. Something that's helpful is to add in a line right here between intrusive and extrusive igneous rocks. You can think of this line as the surface of the Earth, or the ground level. Any rocks that form above the line are going to be extrusive because they have exited the Earth, come out of a volcano someplace. All the rocks that form beneath the line are intrusive. They form inside or underground. They form inside the Earth. And so that is the first major sort of differentiation between the types of igneous rocks. Intrusive rocks have larger crystal sizes, so 1 millimeter or larger, and crystal size is directly tied to texture. If we take a look at granite, for example, the igneous rock granite is an intrusive igneous rock, so it forms underground, and we know or infer that it's intrusive because it has a crystal size between 1 to 10 millimeters, has a coarse, non-vesicular texture. All right, so how do we start looping in some of the characteristics and the mineral composition to this? It's actually quite easy. You just need to kind of know what you're doing first. We can just drop a line straight down to the bottom, and we can see that granite falls towards the lighter side of the color spectrum. And because it's lighter in color, we know that it has a relatively lower density than darker igneous rocks will. And we say that its composition is more felsic. That means it has more silicon and aluminum in it. And then in the very bottom chart, we can see it has potassium feldspar, quartz, plagioclase feldspar, biotite, and amphibole in its composition. How would granite compare to the igneous rock gabbro? Well, gabbro is also an intrusive or plutonic igneous rock. It has a similar crystal size, 1 to 10 millimeters, and it also has the same texture. It's coarse and non-vesicular. But where gabbro differs from granite is in its color, density, composition, and its mineral content. So gabbro is on the darker end of the spectrum. Because it's darker, we know it's going to be higher in density. Because it's more mafic, it has more iron and magnesium in its composition. Right, so the minerals that make up gabbro tend to have more dense elements in it, such as iron and magnesium, so plagioclase feldspar, pyroxene, olivine, and a little bit of amphibole here. Okay, so let's look at an example of a typical regions question. Let's imagine that we know we have a rock that is lighter in color, lower in density, or sort of on the felsic end of the spectrum. So we know we're looking somewhere on the left-hand side of the diagram. We also know that that rock is extrusive. right? In addition to knowing that it's extrusive, we know that it's vesicular and has a fine texture with crystal sizes less than 1 millimeter. So you need to combine all this information and figure out where they intersect. Right? The most restrictive box is around the vesicular fine texture. So it has to be somewhere in this region because we know it's kind of on the more felsic compositional side. We know that we are looking at the rock vesicular rhyolite. Another example, let's imagine that we're looking at an intrusive igneous rock. So right off the bat, we can draw our box around just the intrusive rocks. Now let's imagine that this rock has 100% olivine in it. We know it's just made of the mineral olivine. So we're going to take a look down at our mineral composition chart at the bottom. We're looking for a rock that's made of only olivine. So we come all the way to the right where olivine starts at the bottom of the chart, goes all the way up to the top. We're looking at the igneous rock dunite.